What are we doing? Okay, so number 20 on the L'Hôpital's rule paper. From the L'Hôpital rule. So it says find the limits as x approaches infinity of x times pi over 2 minus the arctan of x. Okay. So you have to know something here. Okay. Who has this question? Marvin?
Yes.
Okay. So you have to know something here is that when the arctan of infinity, we talked about this. Okay. So arctan of infinity, did we speak about this?
I think
Yes,
you said
we did.
pi over 2.
Oh, very good. So this is pi over 2. Okay, so the graph, just a reminder, okay, the graph of the arctan is like this. So there's an asymptote at pi over 2 and at minus pi over 2, y, x, and this is the graph. I think I showed you this already. Okay, and this is pi over 2. And this is minus pi over 2. So as x goes to infinity, right, the function gets closer and closer to pi over 2. That's why as x approaches infinity, this becomes pi over 2. Okay, so what do I have? X is infinity times pi over 2 minus pi over 2 is 0. So I have infinity times 0, which of course is an undetermined form. And what do I do? Any suggestion?
Can you divide it by 1 over x?
Very good. Okay, very good. That's what I would have done as well. I didn't do this exercise, but I would have done this so that I could use L'Hôpital's rule. So limit x approaches infinity. So pi over 2 minus the arctan of x, and this divided by 1 over x. Perfect. Okay, so now I have 0 divided by 1 divided by infinity is 0. So now I have 0 over 0, which is the undetermined form that allows me to use L'Hôpital's rule. And so I'm going to put h for L'Hôpital's rule, limit as x approaches infinity. And I need to do the derivative of the top. Do you remember what that is? The derivative of pi over 2 is?
Is 0.
0.
Yeah. And then minus the derivative of the arctan is?
I think 1 over 1 plus x over 2.
Yeah. 1 over 1 plus x2. Okay, so this we showed, we proved, you're thinking, but you shouldn't think anymore. At this point, that's it. It has to become natural. Okay, and then all this divided by derivative of 1 over x is, we know it's negative 1 over x2. Is this okay?
Yes.
Okay, let's simplify the minuses. And now I have limit as x approaches infinity. And if I divide a fraction by a fraction, so I'm multiplying by the reciprocal, x2 over 1 plus x2. All good? And then what do we do? This is infinity power 2 is infinity divided by 1 plus infinity is infinity. I could do what again? I could use L'Hôpital's rule again. Okay, or another method at this point to find the limits, whatever you prefer. Okay, and that's limit x approaches infinity. The derivative of x2 is 2x. The derivative of the bottom is 2x. And you cross them out. And so my answer is 1. Okay, so this limit is 1. Does that answer you, Marvin?
Yeah, thank you.
Okay, next. You told me number 22.
Yes.
Okay, 22. Let me see that. Let me see if I could fit it here on this paper. So number 22, still in L'Hopital's rule. So limit as x approaches 0 of cos x to the power of 1 over x2. Okay, so if I plug in 0 inside, so the cosine of 0 is 1, and 1 divided by 0 is infinity. So this gives me 1 to the power of infinity. This is an undetermined form. I cannot use L'Hopital's rule. What do? You remember? I guess you don't. We call this limit L. And then what do? We take the ln on each side. Ln here, ln here. Okay, and that way I could bring the exponent in front. So ln of the limit is limit as x approaches 0, ln of cosine of x divided by x2, right? Times 1 over x2, which is in front. So it appears on the bottom. If you plug in 0 here, cos of 0 is 1, ln of 1 is 0, and on the bottom 0 power 2 is 0. I could use L'Hopital's rule. Equals, using L'Hopital, limit x approaches to 0, and now I do the derivative of the top, same rule. So 1 over the cosine of x times the derivative of cosine, which is negative sine, and divided by 2x. Any questions so far, Marvin?
No, so when we have an undefined form, we do the ln, and then we do it like
when you have one of this undetermined form, yes, like this.
okay, and then we do ln, and then we do like the product rule normal.
And then you do the properties of the lns until you arrange it until you get into 0 over 0 or infinity over infinity. Then you could use L'Hopital's rule.
Okay, perfect.
Okay, and let's finish it off. So it's equal to limit as x approaches to 0. So negative sine x over 2x cos x. Right? That's what it is.
Yeah.
And now I could use L'Hopital's rule again because I still have 0 over 0 here. Right? Sine of 0 is 0, and on the bottom x is 0, times 1 is 0. So let's do L'Hopital's rule again. Limit as x approaches 0. The derivative of the top is negative the cosine of x. And then the derivative of the bottom, don't forget to use the product rule. So 2 times the cos of x minus 2x sine x. Okay, plug in 0 in the x, you get minus 1 on top, you get 2 here, and you get 0 here. And so my answer is negative 1 over 2. There you go.
Draw a question.
Sure.
What happened to ln of L?
Oh, you're right. I'm not done. 100%. You're right. So this is just ln of L. And so ln of L is equal to negative a half, which means that L is what? E power negative 1/2. There you go. You're right. 100%. Everything I found here was just the ln of the limit. So if I want to find the limit, I do e power that, and I'm going to get the limit. Okay. Any questions, anyone? Okay. All right. If If you have no more questions, I'm going to start the review, okay? So what I'm going to do, and it's what I did with the other group, I'm taking questions from old exams, okay? And we're going to do them together. Okay, so that's going to help a lot. Okay, so here's one right here. So let me tell you what I'm looking for here. Sorry. So you see a function, a piecewise function that's a bit weird. There's a jump, a hole here. Okay. And let me ask you a few questions. So A, I want the limit as x approaches negative infinity of f of x. B, the limit as x approaches positive infinity. C, the limit as x approaches -3. D, the limit as x approaches 2 from the left side. E, limit as x approaches 2. F, limit as x approaches -1. G, limit as x approaches 0 from the right. H, I want f of -3. And I find, oops, I don't know if you could still read, find the values of x at which f is continuous but not differentiable. Okay, so this is the question. Okay, so this is a question from an exam, and it's really, it's a topic that we did probably the first week of classes. Okay, we worked on this. So let's go. Let's start answering the question. So the limit as x approaches -infinity of f of x. So I'm going to ask someone. Let me see. Gabriela, you here? No, she's not here. Okay. Arena? Oh, nobody's here? Okay. Let me see. Jelly? Okay. Amanda? Everybody scared? Okay, Evan, I see you. Tell me, what's the limit x approaches -infinity?
Positive infinity.
Yeah, very good. Positive infinity, because of course, if x is getting very, very small, you see the function is getting very, very high. So it's plus infinity. Okay, we understand this. Limit x approaches positive infinity. Jeremy, wanna try? Jeremy.
Isn't it just 2?
Yeah, well, why are you answering me with a question?
I'm not sure. I can't really see it.
Oh, you can't, oh, because you can't see the level, you mean?
Oh, yeah, I can see it now. It's 2, yeah.
Okay, it's 2, okay. Good, you're right. Okay, so this is 2. Limit x approaches -3. Georgia, we try?
You just skipped my turn.
No, no, no.
I don't want to try it.
You don't want to try it?
No.
Why not? You don't know what to do it?
No, I kind of forgot this whole chapter.
Okay, so that's good. That's the purpose of the review. Review means for what you forgot. Let's go back to it. So let's go. Let's learn it now.
Okay.
You're gonna learn something. Okay, so x approaches -3. What if x is getting close to -3? What is the y getting close to?
1.
Yeah, 1, right? If I get close to -3 here, the function is getting close to this hole here, and that means that the y is getting close to 1. Perfect, that's 1. Wasn't that bad, no?
No.
Okay. Okay, limit x approaches 2 from the left. Gabriela. All right. She's trying to hide. Harun.
Is it 2?
So if I'm approaching 2 from the left side, perfect, it's 2. Everybody understands this? All right. Limit x approaches 2. Let me see. Marvin, you want to try?
Is it DNE?
Very good. So does not exist. Perfect, because if I approach 2 from the left, I'm getting close to here. And if I approach 2 from the right, well, I'm going to infinity. So obviously, left and right are not the same. The limit does not exist. -1. Anna? Want to try?
Is it -1?
Again, you answer me with a question, like Jeremy?
I don't really. Okay. Okay, I see. It's -1.
Okay, that's better. Okay, -1. Okay, if you answer me, and even if you get it right and you're not sure, it's not good. You have to be sure. Okay, I want confidence. Okay, 0, x approaches 0 from the right. Guillaume, you want to try?
Wait, which one? H?
G. If approaching 0 from the right.
It's 0, I think.
It's 0. Perfect. Okay, the closer x gets to 0, the closer the y gets to 0 as well. Okay, f of -3, Fetame. It's good what I'm doing now. Now I see you sleeping. Okay. I woke you up, Fetame.
Is it 2, 1? I don't see 1.
What is this? You're asking me a question? I ask the questions here.
I have no idea what's the answer.
You have no idea?
I don't know. I think it's 1.
You think it's 1? Why? What else could it be? Why are you hesitating with?
I don't know. Me too. I didn't really understand this chapter.
Well, it's very good that we're reviewing that. Okay, so again, -3, when x equals -3, what is the value of the function? What is the value of the function at -3? So when x is -3, where is the dot? It's at 3.
Oh, I didn't see the dot. Sorry.
Okay. You thought it was a stain on the paper?
I
Okay.
didn't.
3. Any questions so far? Okay, let's go. Find the values of x at which f is continuous but not differentiable.
Can you repeat number H?
Of course. Who's asking this?
Sophia.
Sophia. So number H. So I want to know what is the value of the function at x equals -3. Okay, so how do I know what the value of the function is at any value of x? Well, it's very simple. Imagine, okay, and that's every function that you're going to do in your life. Okay, imagine you're walking here on the x-axis. You're walking here with an infinite pole. Okay, you have a pole, an infinite, and you're walking with the pole like this. You're walking, 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 walking. Okay, as soon as the pole touches the function, well, you get, as soon as it touches something, you get sort of a shock, and that tells you the height, and that's the y. Okay, so if you walk here, you walk, you walk, you walk, you touch, and this is the value of the function, value, 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 value. When you get to this hole, right, your pole passes through the hole and it touches this dot. So that's why it's 3. Do you understand, Sophia?
Oh,
What?
yeah. Yeah, it's
Sure?
okay. I didn't see the dot before.
What's with the dot, guys? You don't see it?
Yeah, I didn't.
Should I made it bigger? Okay, let me erase this little guy here. Okay, let's go. Find the values of x at which f is continuous but not differentiable. Can you tell me, anybody?
When x is -1.
When x is -1, very good. Okay, so when x is -1, I'm going to explain you why. So at x equals -1, what happens? The function here is not differentiable because there is no tangent line. Okay, so not differentiable means there is no tangent line. Okay, you cannot find the tangent of a pointy part. Makes no sense. If it's curvy, like here, yeah, you could find a tangent, you could find a tangent and tangent, no problem. Here you can't. Okay, so that's why at x equals -1, the function is not differentiable. Why not at 3? Did you tell me 3? Why didn't you tell me 3? Anyone?
Is it because it's not continuous?
Very nice. Okay, very good. At 3, it's not continuous, and the question says, find the values where f is continuous but not differentiable. And like you said, very good. At -3, it is not continuous. As you see, I cannot draw my graph without lifting my pen. It's not continuous. Okay, and so continuous means you could draw without lifting the pen. Differentiable means there's no pointy part. It's very smooth. That's it. Okay, that was question 1. Any questions? Why not 2? Who said why not 2? Okay, I'm getting a chat in the chat. The question is why is it not differentiable at 2? Well, at 2 it is not differentiable, of course, because the function is not even defined at 2. And on top of that, it's not continuous because, as you see, there is an infinite jump there. It's not continuous. Okay, I hope it answers your question. Okay. We move on. Okay, let's go. So let's do a few more examples. So let's evaluate some limits. Okay, so we're still at the beginning of the course, probably the first week or so. So number 2. So evaluate. A limit as x approaches 2 of x2 plus 2x minus 8 divided by x4 minus 60.
Sir, I have a question for the final.
Yes.
Are you gonna ask us when you want us to use L'Hopital rule? When you want us to use?
No, you'll be able to use it as you wish.
Okay.
Okay, so here you could use L'Hopital's rule or you could use factoring, whatever you prefer. Okay. The only thing I'm going to require for you to do is if I ask you to find the derivative using the definition. Okay. If I specify that, then you have to use the definition. Otherwise, you could use any technique that we've learned. Okay, the product, quotient, all the rules. Okay. So let's go. So what do you suggest to do here? First thing we do, what is the first thing we do?
Plug in 2 and see if it gives us 0.
Perfect. So I plug in 2 here. Let's see what happens. 2 power 2 is 4. 4 plus 4 is 8. Minus 8 is 0. And on the bottom, I get 2 power 4 is 16 minus 16 is 0. So this gives me 0 over 0. So obviously this function here does not work at x equals 2. Okay, because at x equals 2, I get my calculator. If I plug in, then it just explodes. Okay, so what do I need to do? So either I do L'Hopital's rule because I have 0 over 0, or I factor. So might as well, I'm going to do both. Okay, I'm going to do both. So using L'Hopital's rule, and then say using factoring. Okay, so of course on the exam you use whatever you prefer. So using L'Hopital's rule, limit x approaches 2, and I do the derivative of the top, which is 2x plus 2 over the derivative of the bottom, which is 4x cubed. And then you plug in 2 inside. I get 2 times 2 is 4 plus 2 is 6 over 8 times 4, which is 32. And that gives me 3 over 16. Okay, and then using factoring, limit x approaches 2. So I'm going to factor the top. I get x minus 2 times x plus 4. And on the bottom, if you factor, you get x2 plus 4 times x2 minus 4, which is x minus 2, x plus 2. Cross out the 2's, the x minus 2's. And so we get, if you plug in 2 inside, I get 2 plus 4 is 6. And on the bottom, I get 4 plus 4 is 8. 2 plus 2 is 4. 4 times 8 is 32. And so I get the same answer in both ways. Okay? Any questions? Let's move on. B. Limit as x approaches pi over 3 from the left side, sine x over 1 minus 2 cos x. So what is the first thing I do? Plug in pi over 3 inside. Okay, so sine of pi over 3, so pi over 3 is 60 degrees. Sine of 60 is square root of 3 over 2. And then the cos of 60 degrees is a half. A half times 2 is 1. 1 minus 1 is 0. So I get root 3 over 2 over 0. And so you remember when we have a number over 0, it's either infinity, minus infinity, or doesn't exist. You remember this? Okay, so let's go. Let's see which one it's going to be. So limit x approaches pi over 3 from the left, sine x 1 minus 2 cos x. So the top, there's no problem. It's root 3 over 2. And the bottom, so let's analyze the bottom now. It's telling me that x is pi over 3 from the left, which means that it's just a little bit less than pi over 3. So let me draw my circle. Okay, so I'm going to draw my unit circle. And this is about 60 degrees. Okay, and this is the cosine, right? You remember that this is the cosine. If my angle is just a little bit less, it's a little less than pi over 3. That means that my cosine is a little bit bigger. You understand? It's a little bit bigger than a half. And therefore, if this is bigger than a half, then this will be a negative number. Okay, so this is a bit more tricky. Okay, and so we have a positive divided by negative, so we get a negative, and a number over 0 is infinity, so I get negative infinity as an answer. Questions? All right, C. Limit x approaches 4 minus x over square root x plus 5 minus 3. Sorry, it's a bit crooked. Okay. Let's plug in 4. 4 minus 4 is 0 over 4 plus 5 is 9, square root of 9 is 3, 3 minus 3 is 0. All right, so what can I do here?
Rationalize.
I could rationalize, good, or I could use L'Hopital's rule. You have the choice, whatever you want. Okay, I think I would do L'Hopital's rule, it's easier, but you could rationalize if you want. Okay, so equals, using L'Hopital's rule, limit as x approaches 4, the derivative of the top is -1, and the derivative of the bottom is 1 over 2 square root of x plus 5. And that is the limit as x approaches 4, flip, I get -2 square root x plus 5, plug in 4 inside, 4 plus 5 is 9, square root of 9 is 3, 3 times 2 is 6, so -6. All good? Okay, let's keep going. Okay, I'm going to post all these sheets right after. And the video as well. D. Limit as x approaches infinity, or negative infinity, sorry. X approaches negative infinity of big square root 2 plus 9x divided by 5 plus 4x. So for now, I find this exam pretty easy. You should too know. You find it easy? Pretty straightforward. I think it's easier than our midterm. Okay. So again, I plug in infinity here. Negative infinity over negative infinity is the same thing as infinity over infinity. Okay, so I could definitely use L'Hopital's rule. I'm just going to put the limit inside. So square root of the limit x approaches negative infinity, 2 plus 9x over 5 plus 4x. And I'm going to do L'Hopital's rule. Square root limit x approaches negative infinity. Derivative of the top is 9. Derivative of the bottom is 4. So it's just 9 over 4. Square root is 3 over 2. Easy stuff. Of course, it's much easier when I do it. But you'll see. We'll do over the next few classes, we'll do a lot of review. We'll do a few hundreds of problems, and eventually you'll see it repeat itself, repeats, you'll get the hang of it. E, limit x approaches 2, x ln x minus ln of x2 over x minus 2. So 2 times ln 2 minus ln of 4, this is going to be 0. And 2 minus 2 on the bottom is going to be 0 as well. Okay, so I could use L'Hopital's rule here, but I think there's an easier way. Do you see the easier way to do it?
If you add 1 to the limit, I think they would end up canceling out.
If you add ln to the limit, how would you add ln here?
Like when you make it equal to L and you add 1 to both sides.
No, this you would do when you have an x in the exponent.
Oh, okay.
Okay. In this case, it won't help you. Anytime you have a sum or a difference, it's finished. You can't use really the ln. It's not useful. But there's something else you could do.
Can you factor out the ln?
But it's not the same. This is ln x, this is ln x2.
Have to move the exponent, the 2, before you factor.
Very good.
one of
Okay,
it.
so let's do this. Let's use the properties of ln that you learned in high school. So x ln x minus, so this exponent you could bring in front, 2 ln x over x minus 2. Okay, you understand this step? And now I could factor out ln x. Ln x times x minus 2 over x minus 2. And now these ones, they cross out. I plug in 2 inside, you get ln of 2 is my answer. Any questions? That was number 2. Okay, let's go number 3. So is this okay so far? Is it bringing back memories? Number 3. So here we go. I have a piecewise function here. So the absolute value of x minus 2, the square root of x minus 1, and 2x over 10 minus 1. This one over 10 minus x. This is if x is less than or equal to 1. This is if x is between 1 and 5. And this is if x is greater than 5. Okay, the question is, find all values of x where f is not continuous. Okay, and justify your answers. Okay, or just, okay, and also classify, I'm gonna write like this, the type of discontinuity. Okay? So now I'm listening. What do you suggest that I consider as possible problem points, problem values?
When each piece of the function connects with each other.
Okay, so tell me. So potential, let's call it like this. Values. Okay, so it will be x equals what?
1
1
or 5.
Or x equals 5. Very good. Because that's where at 1, these two functions connect, and at 5, these two functions connect. Another, you have another value that we should watch? I see another one.
10.
10. Very good. You understand why 10? Why?
Because for the third function, if you put 10 in it, it's gonna equal to 0. Or no, infinity, sorry.
Exactly. Because this function, this branch here doesn't work at 10. At 10, there's a problem. Okay, so these are values, these are the only values of this function that I should really watch carefully. Okay, so at 1, let's see if they connect. At 5, let's see if they connect. And later on at 10, this function seems to have an issue. So let's now take care of each of these. Okay, so let's see what happens. This is a long problem. So let's see at x equals 1, what happens. Okay, so you remember we do the limit from the left and the limit from the right. So the limit as x approaches 1 from the left of my function is what? And then the limit as x approaches 1 from the right of my function equals what? So on the left and on the right. So on the left is what? Left of 1 is this function, absolute value of x minus 2. And on the right of 1 is this function, square root of x minus 1. This gives me, if I plug in 1 here, I get 1 minus 2 is -1. Absolute value of -1 is 1. And then here, 1 minus 1 is 0. Square root of 0 is 0. So limit as x approaches 1 of f of x is what?
Does not exist.
It does not exist because from the left and from the right, they don't approach the same value. So it doesn't exist. So we have a discontinuity at x equals 1. What type of discontinuity? How do you call? How do you call this type of discontinuity? Forgot?
Wait, can you repeat the types?
A jump?
It's called a jump. Okay. Jump discontinuity. Okay. It's a jump. You're going to see the types in a minute. We're gonna all 3 types are going to be here in this question. Okay, at x equals 1. Okay, so it seems that at x equals 1, if I were to draw the function, okay, it would be something like this. So at 1, okay? At 5 and at 10. We're going to talk about this in a second. So at 1, what happens? At 1, it seems that if I get close from the left, I'm getting close to 1. I don't care what it looks like. And including, because it's or equal. From the right, I'm getting close to 0. So it seems to be something like this. Open dot. Okay, so you see that the function jumps here. Clear? Okay. Let's see at x equals 5 what happens. Oh no, we're not done. So well, okay, that's it. At x equals 5, what happens? Again, we do the same process. So let me just move up a bit. Okay, so at x equals 5, I'm going to do the limit from the left. Yes, 5 from the left of f of x equals, and then limit as x equals 5 from the right. Okay, I get left is limit x approaches 5 from the left. So the function on the left of 5 is the square root of x minus 1. And on the right, limit x approaches 5 from the right is going to be the other 2x over 10 minus x. Plug in 5 here. 5 minus 1 is 4. Square root of 4 is 2. And here, 2 times 5 is 10 over 5 is 2. Oh, limit exists. Limit x approaches 5 of f of x is 2. You with me? Okay, let me just see what's happening here. It seems, if I am to complete my function here, it seems that at 5, whether you approach from the left or from the right, you're approaching 2. Okay, more or less. Now, what is the other thing I need to check? I need to verify. What is it?
The value of x.
Very good.
5.
So f of 5, what is that equal to? So let's go back to my function. And f of 5 is what? So I need to look for the equal. Oh, there's nothing. So the function is not defined at 5. Okay, so the whole stays empty here. Okay, so is not defined because there's no or equal there. So we have a discontinuity there. What type of discontinuity? You remember what it's called?
Removable, I think.
Yeah, very good. Removable discontinuity at x is equal to 5. Any questions so far? Okay, let's see what happens now at x equals 10. Do I have space to fit it here? I think I'm going to try. So at x equals 10, so I will do the limit from the left. Of f of x is equal to the limit x equals 10 from the left, 2x over 10 minus x. What is that going to be? I will have 20 on top, and on bottom I have 0. But since I am a bit less than 10, so this is a positive number, so 0 plus, so I get positive infinity. And from the right, of f of x, I will have limit x approaches 10 from the right of 2x over 10 minus x, 20 over 0 minus, and so I get negative infinity.
Sir, can you just explain again why is it plus infinity?
Why this is plus infinity? Yeah, because if you plug, okay, because if you plug in 10 here, you will get 20 over 0. That you agree?
Yes.
Okay, now 20 over 0, I need to determine what is the sign of the 10 minus x. Okay, so if x is a bit less than 10, so if it's 9.99999, this is going to be a positive value.
Oh, okay, okay.
That's why it's going to be positive infinity. Okay.
Yeah.
Okay, so if I am to go back to my graph, okay, so what happens here? At 10, I seem to have an asymptote. And as I'm approaching 10 from the left side, we said it was plus infinity. And if I approach 10 from the right side, it was minus infinity. So my graph looks something like this. Okay, and so there's a type of discontinuity which is called an infinite discontinuity. Okay, I'm gonna write like this. There is an infinite discontinuity at x equals 10. That was question number 3. Any questions? All right, let's go. Let's keep going. Number 4. So, A, use the definition of the derivative to find f prime of x, okay, or f of x is equal to 2x over 5 minus x, okay, and B, use derivative rules to verify your answer. Okay, so now we're moving into the derivative part. So the first 3 questions were on limits and continuity. So now we go question 4, it starts with derivatives. Okay, so using the derivative rules, obviously, it would be using the quotient rule here. Okay, so let's go. A. You remember how to do this? F of x plus h was 2 times x plus h over 5 minus x plus h. Okay, f prime of x is the limit h approaches 0, f of x plus h minus f of x, all this over h. Okay, we know the formula, f of x plus h minus f of x over h, h approaches 0. Question? All right, so now we have to do just some algebra, okay? Equals limit h approaches 0, so I'm going to find the common denominator on top. 2x plus h times 5 minus x minus 2x times this here, which is 5 minus x minus h over the common denominator of 5 minus x minus h times 5 minus x. Good. This is the top simplified. And all this divided by h or times 1 over h. So basically I could just put h here. Questions? Okay, now we just have to simplify the top as much as we can. So I'm going to just open everything up. So I have 10x minus 2x2 plus 10h minus 2xh minus 10x plus 2x2 and then plus 2xh. That's what I have on top after simplifying. And now I can start crossing out stuff. 10x minus 10x minus 2x2 plus 2x2 minus 2xh plus 2xh. And so I have on top, I just have 10h. And on the bottom, I have h times 5 minus x minus h, 5 minus x. h's are out. And now I plug in the h is 0. So it's 5 minus x times 5 minus x and 10 over that. So I get 10 over 5 minus x squared. Sorry, you can see. There we go. Any questions? Okay, good. Let's go. Second part is using the derivative rules. So let's use the quotient rule. So the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. U prime v plus u minus u v prime. And so that is 2 times 5 minus x minus 2x times minus 1 over 5 minus x squared. And so on top I have 10 minus 2x plus 2x is just 10 over 5 minus x squared. And so I just verified that it works. Oh, again, you can see, sorry. That was number 4. Questions? Anyone? Want me to slow down? All right. Number 5. Okay, so 5 is just all out derivatives. Find y prime. A. Y is equal to 3x2 minus 9 times secant 4 of 5x plus 3. Okay, so here there is a multiplication, so we have to do, of course, the product rule. Let's go. Y prime equals u prime v plus uv prime. So let me do at least the first one. I'll do the steps. U prime v plus u v prime, which is the derivative of this is 6x times secant 4 5x plus 3 plus 3x2 minus 9 times the derivative of secant 4 is 4 times secant cubed 5x plus 3 times what?
5.
No, you're missing something. So we derived the power 4, okay? We didn't derive the secant yet. Okay, so I'll do the step. Secant 5x plus 3 prime. Do you understand this? No?
Yeah.
Okay, so be careful. Don't forget the steps. There's 3 steps here. You have to derive the power 4, then the secant, then the 5x plus 3. Okay, so let's go. Equals 6x secant 4 5x plus 3 plus 3x2 minus 9 times 4 secant cubed 5x plus 3 times the derivative of secant is secant 5x plus 3 times tangent 5x plus 3, because the derivative of secant is secant times tangent, and now times the derivative of 5x plus 3, which is 5. Okay? So the only thing I could do here, I could factor out because I have a secant 4 and a secant 4, so might as well pull them out. Okay, so even a 2, I could pull a 2 here and a 2 here. So I'll pull out 2 secant 4 of 5x plus 3 times, so what's left here? Just 3x plus, and here the secant 4s are out. 5 times 2 is 10 times 3x2 minus 9 times tangent of 5x plus 3, and that's my answer. Okay, so I did an extra step here of simplifying this, factoring it out. Sometimes it's useful. Questions? B. Y is equal to ln of x2 minus 9 to the power of 4 over x cubed times the square root of x plus 7. What do you suggest we do here?
You could do ln of the numerator minus the ln of the denominator.
Very nice. Okay, so let's use the properties of lns before doing the derivative. So ln of this will be 4 ln of x2 minus 9 minus ln of x cubed, which is 3 ln x, minus ln of the square root of x plus 7, which is 1/2 ln x plus 7. Okay, are you okay with this? They're just the properties of lns, of logs. Okay, and now I could derive easily. So y prime, the derivative of this is 4 over x2 minus 9 times 2x minus 3 over x minus 1 over 2 times x plus 7. And that's going to be my answer. Okay, just simplify it nicely. So 8x over x2 minus 9 minus 3 over x minus 1 over 2 times x plus 7. Questions?